First of all, I want to start by thanking SciPy for giving me the opportunity to share my work with you. And my main area of focus is on defining standards to improve the reproducibility of computational results, and also on bringing more automation to all scientific computations. So my talk today is about a cloud service to help a scientist to wrap the simulation in a Docker, in a container system like images, to be able to make it reproducible, but also to distribute it to other researchers and enhance collaboration around simulation results. So this project is funded at NIST by the MGI. It's the Material Genomic Initiative. It's a White House initiative to better integrate digital data, experimental data, and scientific tools. So I've been having issues on setting up the projector, but I'm going to just start by saying that the related work in reproducible research have been focusing on the terminology of three different terms: reproducible, repeatable, and replicable, and the opposite of those terms. And also, there are much work that have been done on defining what are the required components from a simulation being run to be recorded to allow other researchers to reproduce or repeat this simulation. And also, there are some work that have been done on defining what are the approaches that simulation management tools should take to record those metadata, to allow other researchers to replicate and recreate and repeat the results that you did. And you can see that this is useful for other people that are in the same field that you are to extend what you did or to apply your simulation on other inputs that you don't have. And also for conferences to confirm the claims that you're putting in your paper about the results that you're putting up. The motivation behind my work was based on two questions. The first one is, how do I take... So the two questions that have been answering, firstly was, how do I take some metadata records from a simulation management tool and make it reproducible? And the answer is that it's kind of a hard task right now. Because already setting up the environment on which the simulation has been run in any general cases is already a not straightforward task. And the second question is, let's say I'm a researcher and I did some simulation, I had some results, and saw that in the literature you did some other research too that is kind of related, and you have some results. How do I communicate with you to share the experience that I had with my result, collaborate with you, and get some insight of what you did, or say that what you did is a repeat of mine, or what you did is a reproduction of mine, or it's not at all repeated or reproduced while we are still working on the same field. So the work that I'm presenting today is giving an answer to those two questions by defining a reproducible record atom that is composed of the metadata about the simulation, but also a container wrapping image that solve the problem of the environment setup. And the second part is I'm also providing a cloud service to allow collaboration around those simulation metadata through a certain scheme of collaboration. So the system is composed of three main components: the project model, the container model, and the record model. So to put it up in a right way is there is a kind of workflow in it, and usually people make a confusion between version control in a global sense and source code version control and simulation recording management tools. Okay, I'm gonna put it in a certain way that simulation management tools are kind of execution version control systems. So they come after version control. It's like you code you have you have a roadmap of features as a researcher. You want to implement this feature, and when you reach the point where you finish implementing the feature, you basically would merge your branch with the master branch or your release branch. This is the point where you should you should run the simulation management tool with the new line of feature that you implemented. And this is where my contribution comes along on giving the researcher a certain way of wrapping his simulation at that point with a container image along with the metadata about the simulation and push it on the cloud so that someone else can go online, see the project, look at all the records that have been done and pull it down and then run it back again like it was done before. Or also there is another case where the researcher wants also to be able to use some other input data and run the same simulation on those input data. So the schema on which you should wrap your simulation is kind of like you have the whole simulation running execution in the Docker file, but you have to externalize all the input files to allow other researchers to use your code with the input files and have an output that you can collaborate with. So there's the main definition about the collaboration is on a name that I'm still figuring out if it's a good one or not. It's called a diff request. So basically, you're a researcher, you have a record in the platform, and you want to say, I saw this result. I think it's related to my result, or it's an extension to my result, or it's a repeat to my result, or it's a reproduction, or I use the same source code, but I don't have the same result. So I want to communicate with the other researcher to say, I think this visually is a repeat of what you did. What do you think about it? So the diff requests have a status that is accepted or denied from the targeted record owner, and it has also a method of in what method did you base your assessment of saying that you repeated my stuff. So did you use a custom one? If you use a custom one, do you have a script that you use to compare our results? Or did you make just a visual assessment? Or did you use a kind of, did you use, sorry. Okay. So this is.
Ignore them.
Okay. So this is how the diff request system is set up so that people can collaborate around the results, so that they can say that they extended someone else's work or they reviewed someone else's work and collaborate around the works that they did. Okay. So the cloud platform that I'm providing is composed of 4 entities. There is a web front end. There are 2 Python Flask web services. One that is the cloud service that is accessed by the front end, and one that is the API service that is accessed by the simulation management tools that you're using to record your simulations. And also there is a database server. And there's actually another space, a storage space for the container images. And it's either a Docker image. It's fine. Okay, so what was I? I was defining the platform, how the platform is set up. There are 4 entities. And basically, what if you want to use the platform? Because you're thinking probably, how do I use it? So you have to, of course, create an account, get an API key, and you have to have a simulation management tool that is compatible with the platform, that implements the API. So basically, you give the API key to that simulation management tool. And basically, also, the simulation management tool doesn't have really to be able to build automatically container images, but it will be useful if it can build the Docker images or the Rocket images dynamically without you having to do that. So the demo that I'm going to give you is is based on there is a script, there is a certain wrap around a simple simulation around generating a distribution content from NumPy into a file. The wrapping in there is based on two main steps: building the image and running the simulation. So you would mainly do things like that. You implement the feature, you reach a point where you want to run the feature, you run the simulation on all the inputs that you have. At that point, you build the container that will wrap your environment, and you push it. From that point, when you don't update, when you're not implementing another feature, or you didn't reach a point where you are going to push another feature, you can run the same simulation on different inputs, and you don't have to push another container image. So the project have a history of container images that are related to the different features that we implemented in the project. And each of them are related to different records that you did on different inputs. So it's kind of a 3D way of interacting with your stuff. So it's pretty much it. So I think I reached the point where I should do the demo. But I can answer questions before. Yes?
Could you just explain more what a simulation management system is?
Okay, so a simulation management system is a simulation execution recorder. So what it does, it would capture your environment variables. It would capture the inputs. It would capture the dependencies of your simulation. It would kind of wrap up all the metadata about your simulation so that you can rely on it and saying that, oh, this is the record that I did 2 years ago, and I didn't use SciPy stuff in there. And now I have this other record that I use SciPy in there, and the results are different because I use better stuff in SciPy to do it. So this is what simulation management tools are for. Yeah.
So you brought up an interesting point of researchers collaborating and comparing results.
Yes.
One thing I kind of see an analogous of are bug reports.
Okay.
For software. Someone posts to a mailing list or something because this isn't working for me. I'm producing this image and it looks completely different or something like that. One of the trickiest part of figuring out what's wrong is figuring out what is different between the two systems. Yes. I'm wondering, is your system set up so that it would take, the metadata for the known system and the metadata for the bug reporter system, and then do a diff, and then just print out what is different, what is the same, and so we can try to narrow down what might be the source of differences.
Okay, good question. So the way that the interaction is set up is that it can be done automatically, but it's pretty much a domain-specific related interest where I have, because this platform is not related to any type of language that you're using. It's related to the simulation management that you're using to track your records. So if you are when you are at the point where you can, when you are pushing the records, the collaboration part now is, I'm a researcher, I have my results, and I see your results. I can rely to it because we are on the same domain. So I can write scripts, I can use our domain knowledge to compare your stuff and say that, oh, what you did is actually a repeat of mine. So, and I can give you that script when I'm creating the diff requests to say that your record and my record are reproductions, and here is why I think there are some reproduction. So it's not in an automatic sense because the way that the platform is done is in a higher level of, it's completely clouded out of the domain-related side of it, but it's more the job of the researcher to say, I think this project that is described there have a record that is related to mine, and here is how I would say that I want to interact with the person that did it the first time.
So the metadata is not collected automatically? The metadata has to be built by the researcher? Or?
No, the metadata is collected automatically, but the assessment of saying that this input can be binary input of an image or any kind of thing.
Right,
and
right. But to have tools be able to report, take the metadata and provide a report to this person, to the collaborators to assess, these are the things that are the same, these are the things that are different. Because one of the hard parts in debugging is
Yes.
finding out that little detail of like 5 libraries down, there was this version of lib whatever versus that version, or this version was compiled with that compiler versus this compiler.
Yes. Yes. Oh, okay. I see.
The ones that are really difficult to find out.
Okay.
But to have an automated report come out and say, this was compiled with that, and like, oh, well, that's really easy to figure out.
I see your point now. Yeah. So yeah, there is an automatic warning flagging stuff about comparing 2 different records. Basically, the metadata would be with each other, saying that you're using a different version of NumPy than mine and something happened, or you use a different version of scikit-learn and something happened on between, or used another operating system and the records is that you used something that is related to parallel numbers generators and the scheduler change, and your code is relating to scheduling, and I have a different scheduling than you had, and there is a huge difference. So the automatic interaction that would happen would be flagging and saying that here are the differences. But the result side of the actual simulation is more related, the system would give it to the researcher to figure out what is the difference in the output data that is done. But the metadata, yes, would be compared automatically. Yeah. Yes?
You mentioned Docker. I was wondering how that fits into everything. This is something where like somebody can just download a Docker image of containing the code and the simulation that I run and run it with the inputs.
Yes. Okay. The setup is you basically will have a bare a basic Docker file, because I assume that not everybody is into Docker or container systems. So you have a researcher area space where you can set up how you install the stuff, all your apt-get install, your pip install, and everything in there. And I'm using a System 76. It's supposed to be. Yeah.
So after this, we need a recording of the problem.
Yes, yes, indeed. And not reproduce it, because, yeah, we don't want that.
Okay, kind of non-conventional talk. In order to do the live demo, I think we have to take you up there.
Okay.
So I guess...
I'll be doing the demo there then. Yes?
The question is, I guess I'm still kind of confused, is this a Docker implementation so you can just take it and do it locally on your machine, or is this something that is more cloud-based? How is this?
Okay, so there is
the demo with it.
Yeah, absolutely. So there is this local work that you do with your simulation where you implement the stuff, you code it, but at the point where you reach the release, as I said, you would have instead of installing it and you're running it in your computer, you basically wrap it with a Docker or a Rocket setup files. So just after you merge it and you want to run it, you then generate the container image that is associated to that. And then you would basically run it with your simulation management tool. The simulation management tool would run inside the Docker image. So now your simulation isn't running in your computer. It's running in the Docker container. And then you push all that to the cloud. So the researcher that takes that down would run it also inside the Docker image container. So you have the same baseline of environment setup that your simulation is running on. I hope.
It's possibly worth mentioning that the simulation, I just Googled to see how good that was as a search term. It's awful. The simulation management system we've been playing with is a thing called Sumatra. So if you want to start searching on things to kind of get an idea where our heads are at, that's the keyword to use.
Good point.
Sumatra.
Good point, yes. So the platform actually right now supported Docker, and I'm working to support Rocket too. But the simulation management tool that is supported is Sumatra. So it's an event-based simulation management tool. So I'm gonna give.
Okay.
Yes, that has been. I'm gonna give the demo now. So as I was saying, the demo is composed of a simple example that is taken from Sumatra. So basically, it's reading some numbers from files to set up a random number generator from NumPy, and then dumping all the distribution generated numbers in a file. So basically, in the setup, you will have a DDS. Okay, I should put it in. I should have told the name. It's DDSM is for Data-Driven Simulation Management Cloud Service. So you would basically put the API key in that file, and here is the Docker file. So basically, you have a setup area that you don't have to touch, and down here you have a research area where you set up. You can add whatever install stuff that you usually do on your computer. You basically do that in there, and this one is it's an Ubuntu 14.04 image that it's going to be run into. So the management script that is here, there will be a better work that will be done on that. It will be based on a tool that would help you easy the building and the running of the simulation. So basically, I'm gonna. So with this script, you can do you can build the simulation and then you can run it also. But when you build the simulation, basically it would have the image, and it would send, if it finds a Docker image in the folder, it would send it along with the metadata. If there is no Docker image, it would just send the metadata. So the test case would be as the following. Those are the demo files. So I'm going to, if I can go. Okay. So basically that's a space where there are some records already. But to run it, I'm gonna go in DSM demo, and all those stuff can be found on GitHub. You can, I can share it to you guys if you want to have access to them. So I'm gonna take down all the images. So basically, you would do this. So this would build the Docker image and wrap it wrap your simulation inside the Docker image. I want also to show you, this is, when you call the API, this is how the metadata is structured. You'll have a body set of metadata. You'll have the information related to the container, and you have some head information related to the dependencies that have been captured, and the input files that have been pushed on, and also the output and the output data. So this type of, where I can see that the extension of this type of cloud service is that after you run, let's say, 1,000 or 500 or just simulation, you might want to write some other stuff that will go through your metadata or the data that you produce to do some more statistical research or some more gathering research around all the results that you produce. So it's not only just the collaboration side, but it's helping you have an access to all the results that you did, and you can pipe it to some other SciPy tools and do more insight. Okay, so I'm gonna start by creating a user account. I'm gonna say user 5, user 5 at gmail.com. Yeah, I'm gonna annoy Gmail. Okay, basically it creates, I'm in my space now, and what I can do is that I can go down here if I can. Yep, I can go down here. Sorry. And I would take basically my API key here. I would copy it, and then I would go to the demo, put it in DDSM Docker token to give the access to my cloud space to the Sumatra tool, and then I should probably show you that the dashboard is empty. So I'm going to show you. So here's the access to the dashboard. So currently there is nothing in there. So what I'm going to do now is run the first, here you should put it in a way that it's the first time that I'm running the simulation, but actually the source code reached a point where I have a feature that I implemented and I want to run the simulation on some input data. Okay, now we're going to run it. Okay, and in my simulation to pass in the parameters that are required by Sumatra, of course, I would say Sumatra ask you to type executable, select Python, and then those are related to Sumatra, and I invite you to take a look at the documentation too. Main.py, and then I'll run it on a file that is default.param, and I'm going to show it to you while it's doing that. So basically right now, it would find that I have a Docker image in my folder. It would push it while creating the project and gather the metadata and send it.
You're going to type executable.
Oh, yeah. Yeah, I missed. Yeah, so I think destroyed. I'm gonna build it real quick. Yeah. Okay. And actually, if you are familiar with Docker, you can set up whatever type of configuration that you want. So right now, it found the image, and it's going to push it in the cloud space where we are right now. So because of bandwidth issues, this would may take quite 3 minutes, 2 minutes. So I can probably go to this section. So before the simulation gets finished. So I would like to thank my PhD supervisors, Dr. David Hill, that he's not here, he's in France, and Dr. Jonathan Geyer, that he's here on the front, and some NIST colleagues, Andrew Reed, Dr. Andrew Reed, that is on the front too, and Dr. Stephen Langer, that is at NIST right now, and also my early collaborator, Dr. Daniel Wheeler, that gave a presentation on SciPy 2013 about Sumatra. And we should go back now to this. And right now, it is all hosted in Amazon, on Amazon Web Services. So I probably need some validation first before I make that totally public, because this is the development bed. It's not public yet. And when it's doing that, I can answer more questions if you are confused. If you have any questions.